Find links in description box. Sam Carana, Arctic News Blog. Temperature rise may soon accelerate even more. Current global temperature anomalies are extremely high, as illustrated by the first image, showing anomalies from 1991 to 2000. The second image shows the rising temperatures of the North Atlantic Ocean. The North Atlantic sea surface temperature was 21.4 degrees Celsius on May 12, 2024. High North Atlantic sea surface temperatures spell bad news for the Arctic, as much ocean heat gets pushed toward the Arctic from the North Atlantic. North Atlantic sea surface temperatures are now getting pushed up strongly from their annual minimum, in line with seasonal changes. Ominously, a peak of 25.4 degrees Celsius was reached in August 2023, i.e. 4 degrees Celsius higher than the current temperature. The temperature rise is hitting the Arctic harder than elsewhere, as illustrated by the third image. One tipping point that threatens to get crossed is loss of Arctic sea ice. Loss of Arctic sea ice comes with albedo change, which constitutes a huge self-reinforcing feedback loop, i.e. the more sea ice disappears, the more sunlight gets absorbed by the Arctic Ocean, further accelerating sea ice melting, while less sunlight gets reflected back into space. Next to the albedo loss, there is loss of the latent heat buffer constituted by the sea ice. Latent heat is energy associated with a phase change, in this case the energy consumed as solid ice turns into liquid water, i.e. melts. During a phase change, the temperature remains constant. Sea ice acts as a buffer that absorbs heat, while keeping the temperature at about 0 degrees Celsius. As long as there is sea ice in the water, this sea ice will keep absorbing heat, so the temperature doesn't rise at the sea surface. And as long as air temperatures over the Arctic are below freezing, sea ice can persist at the surface, maintaining sea ice extent, which may give the false impression that sea ice was healthy, whereas in fact sea ice is declining in thickness. Fourth image. The amount of energy absorbed by melting ice is as much as it takes to heat up an equivalent mass of water from 0 to 80 degrees Celsius. Loss of the latent heat buffer therefore constitutes a tipping point, i.e. once crossed, the Arctic Ocean will heat up at an accelerating pace. As the map, fifth image, shows, much of the thicker sea ice is located away from the North Pole, such as off the east coast of Greenland, and this sea ice is likely to melt away quickly as more sunlight starts reaching the northern hemisphere and temperatures rise in line with the change in seasons. Seafloor methane constitutes a second tipping point. When methane escapes from hydrates that get destabilized by rising temperatures, the methane will expand to 160 times its previous volume and enter the atmosphere with force. Without the buffer constituted by thicker sea ice, an influx of ocean heat could cause large-scale destabilization of hydrates contained in sediments at the seafloor of the Arctic Ocean, resulting in eruptions of huge amounts of methane.